there's all sorts of interesting challenges about scaling renewable energy so it can provide the same level of energy supply as we have at the moment from hydrocarbons, which have, they're extremely dense sources of energy, per unit mass of the energy source. And there's a lot of work, research, and practical implementation of renewable technologies in both, for example, in solar and in wind, where I guess one big challenge is actually having a implementation at a scale that actually makes that a material part of the overall global energy supply. I think one element of that will involve the development of much more effective storage systems for energy. One possible storage is underground as a thermal energy store. I mean, there are other approaches too. There's a lot of work on battery technology that's being developed and will continue to develop. And also, you can have hydro electric storage systems, pumping water uphill and then passing it through a dam. But underground storage of thermal energy is obviously got a huge potential. And already there are some power stations and big building complexes where the waste thermal energy produced in the summer can be stored underground and then reused for low-grade heating in the winter. And there's a number of interesting challenges with that, because it's not only about being able to recover the thermal energy and understanding how, what fraction of the thermal energy you store that you can recover. It's also understanding the temperature at which that water that you draw out of the ground comes back out of the ground, because if it's too cold, then it's not an effective source of energy except for low-grade heating. So there's a number of challenges there, but I think there's all sorts of exciting new research in renewable energy.